The purpose of this tutorial is to show how to simulate CATIA-generated NC code using a given Vericut project template, which is essentially a partially completed project file that will generally include the CNC machine and fixture, CNC machine control file, tooling, and the work offset. This tutorial is primarily designed for students taking eTech 322, but can also be used as a refresher for students in advanced machining courses. Simulating your project before machining reduces the chance of damaging the tools and the machine due to collisions, and can also provide reassurance that your NC program is written correctly. Before starting Vericut, you will want to take your stock CATIA part file used to generate your NC code in CATIA and save it as a .stl file along with your .txt NC code file in your project folder. There are 5 basic steps before you can simulate your NC program. You need to open the template file, load and position the stock file, position your coordinate system, load your tooling, and load your NC program. First thing you want to do is double-click on the Vericut icon on the desktop to load Vericut. Once Vericut is open, you should set your working directory to your project folder. The working directory icon is on the top of the screen. Click on the icon and then scroll through the tree in the dialog box until you find your project folder. Ours is titled Working Directory. Click the file and then hit OK. Setting the working directory will change the default save and open locations to your project folder. Now that the working directory is set, we will load the Vericut template file. Go to File, Open, and then select your Vericut template file and click Open. Now that the Vericut template file is open, we will expand the tree on the left side of the screen. As you can see, the CNC machine, fixturing, CNC control, and default work offset are pre-configured. In the project tree, every placeholder colored magenta has not been configured. However, we will not need to configure all of the placeholders for simulation. For instance, we will not be configuring NC subprograms or saved IP files. Now we are going to load our stock STL file. Right-click Stock and go to Add Model, then Model File. In the dialog box, select your .stl stock part file, then click Open. Now that the part has been loaded, it needs to be positioned in the fixture. To do this, go to the Assemble tab in the Configure Model dialog box in the bottom left of the screen. Locate the part using the mate or align constraints. These are similar to product constraints in CATIA. Mate is similar to a contact constraint, and align is similar to an offset constraint. To correctly position your part to the fixture, you need to constrain the part on 3 axes. First, we are going to click the first arrow and mate the right side of the part to the right side of the fixture. Then click the second arrow and mate the underside of the part to the top of the parallels. Then change the third drop-down box to Align and click the arrow and align the back side of the part with the back surface of the fixture. Now that the part is positioned, we will add a coordinate system. It is standard practice in WWU machining classes to place the coordinate system in the top right-hand corner of the part. Select Coordinate Systems and then click Add New CSYS in the Configure Coordinate System dialog box. Click inside of the Position box, then click the top right-hand corner of the part in the viewer to set the origin of the coordinate system. Then click the Active Coordinate System checkbox in the bottom left of the screen. Now you need to manually update the coordinate system in the work offset. Click the tab under Work Offsets to open the Configure Work Offsets dialog box. Select the To drop-down box and change it to Component Origin, then change it back to CSYS Origin. This will manually update the component origin to the coordinate system you just created. Next, you will load your tooling. Right-click on Tooling and go to Open. Select your tooling file and then click Open. Next, you will load your NC program. Right-click NC Program and click Add NC Program Files. In the NC Programs dialog box, you can expand the Filter drop-down box to view different file types. Select your NC program file and then click the right-facing arrow to move the program to the current NC programs list. Then click OK. At this point, you are now able to simulate your machining program. To view your NC program while machining, you need to open the Toolpath Viewer. Right-click on your NC program and click Edit. Now you can visually see where in your NC code the simulation is while it is running. Before simulating your program, take a look at the Start/Stop options by right-clicking on the rightmost arrow on the simulation toolbar. This opens a dialog box with the options to stop at a collision or stop at a maximum amount of errors or warnings. It also gives the option to start and stop at different points in the program. Now you can simulate your program by clicking the same arrow. While the program is simulating, you are able to pause by clicking the pause button on the simulation toolbar. Pausing allows you to change to single block mode by clicking the thinner right-pointing arrow. This allows you to simulate the program one line at a time. You can also reset the simulation by clicking the up-pointing arrow. Now that you have verified that your program simulates correctly, you will want to save your Vericut project. Go to File, then Save As, and save your project file. Assuming that you had no collisions, errors, or warnings, you can now be assured that your NC program will run safely and correctly on the CNC machine.